Hello, everyone. I'm Sidra Effendi. Thank you for joining me. I'm giving the talk Machine Language Translation, or the Poetry to Shakespearean English. Um, so here is overview. First of all, I go over my motivation for this project, a little bit about the Urdu poetry, Shakespearean English, the data that I have used to train the models, the methods used, and then we'll see the demo. Um, So yeah, starting off, I would say that right now English is kind of dominant language of the internet, but not every country or state or all people speak English natively. So this kind of gives them an opportunity to explore other languages. There's around 7,100 different languages, and you can imagine the amount of art, poetry, and literature that is there to explore in these different languages. On its own, India has 22 official languages, and one of them is Urdu. So this is what Urdu looks like. It's written left to right, has Arabic script, spoken mainly in the Indian subcontinent area. And for the love of my life, I could just never get a good grade in high school in this class, but it seems like the love for the Urdu poetry gonna stay with me. So this is a couplet, or in Urdu called a shair, by Mirza Ghalib, a very popular poet. And this is a translation done by Mr. Bursch. And you can see it's a lovely couplet, 10,000 desires, each one worth dying for, so many fulfilled, and yet still I yearn for more. One of the things, though, is that with poetry, there's a nuance, and there's a cultural relatedness that might not come across in the translation. So I was with a friend of mine who was interested or really into Shakespeare plays. I kind of conceived the idea, and we were like, can we actually convert and translate Urdu poetry to Shakespearean English? Because it would be really interesting to see how the output looks like, but also how would it be received by someone who's into reading Shakespearean English or Shakespearean plays. So this was kind of like a very ambitious, humongous task, and I would like to point out that these two are not translations, but basically it just kind of shows how ambitious our task was. And one of the problems that we faced is that Urdu is a low resource language. This is true for many non-English languages. There's not not much data out there to train the models for many of the NLP tasks. So the idea was that we'll take a high resource language like modern English, convert Urdu to modern English, and then convert modern English to Shakespearean English. So now we had two models. One, Urdu to modern English, another one, modern English to Shakespearean English. So we required data to train both of these models. What we did was called like fine tuning. So we picked some of the pre-trained models, and this was the data that we chose. We have 16,000 lines from 17 Shakespeare plays. This is what Model 2 was trained on. And there is English to Urdu parallel corpus. This is basically Bible and Urdu, and they're translated from Urdu to English. And then these are around 14,371 sentence pairs. So we scraped them from the websites, we aligned these, and then we started our fine tuning. A sample is of the original text. This is a Shakespeare play, Twelfth Night. And then there is a parallel translation of it, modern translation of it. So for the training, we basically used sequence-to-sequence transformers, because translation is basically an encoder-decoder problem. So we're going to encode in one language, we want to decode in the other one. So Helsinki has a lot of models in many different languages that are translating from some non-English language to English. And then there is Shakespeare GP2 model, which is basically a text generation model, and essentially for style transfer. I'll go more over it when we get to the slide, but basically these were the two models that I kind of used to train fine-tuned. These were pre-trained, so I fine-tuned them using the data that I just showed on the previous slide. So this is an output of the Helsinki before we even trained it. As you can see, it performs pretty well. And on this particular data set, it had, I think, a BLU score of 23.2. And this is our candidate, which is what the model kind of produced for this source language. And the reference is the actual translation that we had on hand. Now, if you look at GPT-2, which is a causal language model, it takes a sentence and then it adds to it. Because GPT-2 on its own is trained on Shakespearean plays, you can see that it adds characters in there. So when we fine-tuned it, we did not see that output because we did not have name of characters in there. So that was kind of handled. This is not what we were desiring. And yeah, so we were able to handle that. Yeah, so I have a demo in place. Let's see. I had a demo in place, but I'm not able to share my screen for the Safari browser. Gail, do you think it is something I can be you can help me with?
Yes, unfortunately, this doesn't work in Safari. It only works in Chrome and Firefox.
Okay. Let me see if I can upload this in my. I think I have time, so I'm gonna try and upload it on my Chrome.
Thank you, everyone. While Sidra gets things downloaded, we should be on in just a moment.
So this is my working file. This is the Marian model, which was which basically we train, and then you have the tokenizer. So you tokenize the text, and then you the Urdu text gets tokenized into the model. This is the fine-tuned model that I had, and after tokenization, let's see. So these are different samples of Urdu poetry ghazal that I was playing around with. So ghazal is going to be 6 couplets. I think I gave a sample of I think I gave a sample of 2 of 1 already, and we'll just wait for it to run. So basically what it does is after you have encoded it, then you want to extract the decoder text. So then you apply the decode method to get the modern English poetry. We can right now see what I have already. So as you can see in Urdu, these get perfectly translated, and these are not poetry. Some of them around here are poetry. So you can see that some of them do not get perfectly, and it would be very interesting to see how Shakespearean model, basically the GPT model, kind of deals with it. So This is the GPT model. And again, we tokenize the English text and it does the style transfer. And you can see that the pipeline is of text generation. And this is just the output, which shows the padding in the document. And to train the model, we had used this special token to separate the English text from the Shakespearean text, so you can see that in the output. And for example, if you look at this sentence, which is in modern English, it kind of returns this, and then it has multiple candidates. So, for example, keeping your mind, and it has pretty interesting output for that in Shakespearean English. Let's try an actual ghazal. Oops, I have to load the model again. So as we can see, this is the translation. I would like to point out that it's not necessary, like the output that we saw from this model, we had certain issues, and I'll dive into the limitations and what are the possibilities with this particular project. But if you compare these two translations, you would see that they are not exactly perfect. We do have a BLU score of 13, which is better than some data sets, but it's not as good as, say, 23.2 that was observed in one of the data sets. So here is the generated Shakespearean English. So for example, as a likeness of molten copper, you have as the spirit of the gold, reads mine and mine. So you see that it has a certain artistic nature to it, but we can still, there's like lots of scope of improvement. So let me dive into the limitations and in the sense like what is, sorry, I'm just trying to reshare my slides. Yep. So the limitations with this data set is that I had computational limits. There are much more fancier models like MBART50, BERT that we could use, and I had memory issues that was, I couldn't work around those constraints at that time. There is lack of data. What I essentially mean is that there is no direct translation of Urdu poetry to Shakespearean English, or even Urdu poetry to actually modern English. And one of the biggest reasons for that is transliteration. As you can see, that is basically writing Urdu in English text. So this input can be taken by an Urdu tokenizer. So, but there's a lot of poetry out there that looks like this. But there is definitely a dearth of parallel corpus of Urdu to modern English, especially when it comes to more sophisticated things like poetry and certain kind of prose. Also, Urdu poetry is different than Roman Urdu. So what we see with the Helsinki model is that it's trained on Roman Urdu to modern English. But Urdu poetry has a style to it, so it's almost like a style transfer and kind of generative, like English to Shakespearean English is. So that's, again, one of the challenges that I kind of face. So some of the future work that I hope gets done, because I feel like language on its own, kind of anyone who speaks another language would agree that it opens door to the culture. So there's so much out there to explore, and there's so much need for languages to be represented in the NLP domain on the internet. So I hope that this work can, it can be easily extended to other languages. There's lots of Helsinki models which work with many different languages, so it's a very replicable project. Second, there's lots of scope of improvement. What it requires is data, and if there's computational resources and data, both of those things kind of really improve the output of this of the in the Shakespearean English. And I hope that it gets replicated in some ways. This is my LinkedIn information if someone wants to connect. I also have this model, like the training models that I have, they are up on my GitHub. So I will share the link to it. I have my pre-trained models in a Google Drive. So feel free to use them, download them. And if anyone has questions or wants to collaborate with me, because I am continuing to work to improve this model, I'll be happy to hear from you. Thank you.
Thank you very much. We can take questions now. There is a question. How do you plan on extending to other languages?
So as I said, that there's lots of Helsinki models that can be used. Also, Embark can be used because they have been trained on many different languages. One of the main constraints that comes is data. With any of the low resource languages, there's not much data out there that we can use to train the NLP models. So I would say and it sounds like it's even true for me, I speak at least 2-3 different languages, and I would love to see them represented. What it means that there has to be work done to kind of create that parallel corpus. I have been attempting to do that, but as I said, there is certain issues that I'm running into, like transliteration. But hopefully, I want to resolve that and basically enrich the data and basically create a data set, parallel corpus, I would say.
Perfect. Would you like to share any other questions?
Sure, I see in the comment that somebody's saying that they would love to collaborate. Yeah, I would love to. I would love to be able, like, I'm always available. I would love to share my work, and if somebody wants to create in a different language or in the same language, I can definitely help out. I have code that I use for training that I think is definitely replicable.
Awesome. All right. There seems to be no more questions, and we would like to thank you very much for your time and hope to see you again in the next conferences. Take care.
Thank you so much.